In this question, what is being asked is that an aircraft loops the loop of radius 500 meter with a constant velocity of 360 kilometer per hour. So let's change this 360 kilometer per hour into meter per second. So 360 into 5 by 18 is nothing but 100 meter per second. Find the weight of a flyer of mass 70 kg at the lower, upper, and middle points of the loop. So this is a loop. Yeah. Okay. So out here, the plane is moving with velocity v is equals to how much? 100 meter per second. Now, is there any centripetal force acting on this plane? Of course. Who is providing that centripetal force? The wind is providing the centripetal force on the wings of the aeroplane. That is changing the direction of this aeroplane in this circular orbit. And what is the value of the centripetal force or the force of lift? Force of lift is equals to centripetal force is equals to mv square by r. But this portion is nothing but the v square by r is nothing but the centripetal acceleration towards the center. This is nothing but centripetal acceleration. So this block or this aeroplane will have a centripetal acceleration towards the center. Okay. Now my question is, what is the radius of the circular orbit? 500. Okay. Now see, if I zoom onto this aeroplane out here, okay, a weighing scale is kept out here. On top of that weighing scale, a 70 kg block is kept. Okay. Now the question is asking, find the weight of this block on the weighing scale. See, a weighing scale always measures the normal reaction force acting on it. Whenever you are asked to find out weight in a non-inertial frame, always find out the normal reaction force on the weighing scale. Okay, so note, a weighing scale always measures the weighing scale always measures the value of normal reaction force acting on the weighing scale. So if I want to analyze this 70 kg block from the frame of reference of the aeroplane, okay, from the frame of reference of aeroplane, what is the weight of the 70 kg block? See, 70 kg block downward would be mg, upward would be normal reaction force. Okay, okay. And where is the centripetal acceleration? Towards the center. Okay, is this frame of reference non-inertial? Yes, this frame of reference has an acceleration that is directed towards the center. So whenever you are seeing any object from this frame of reference, that will experience a pseudo force, and that pseudo force is called centrifugal acceleration, which is equals to mv square by r in the opposite direction to the acceleration of the frame of reference. See, the frame of reference is accelerating towards the center, so centrifugal force or the pseudo force would be outward. Okay, and the effective acceleration is equals to 0 when seen from this frame of reference. So if we draw out the equation, n minus mg minus mv square by r is equals to 0, or n is equals to mg plus mv square by r. Okay, now see, when the block reaches at the topmost position, okay, or when the block is reaching at this position, topmost position, okay, is moving with velocity v. Okay, so out here, if I see the same diagram, out here it would be the weighing scale and a mass would be kept out here. So if I draw the diagram, weighing scale and mass of 70 kg, okay, and the acceleration of the aeroplane or the centripetal acceleration is directed towards downward. So if I draw the free body diagram of the 70 kg block, downward would be force mg. Okay, normal reaction force would be downward. This is the normal reaction force exerted by the weighing scale on the 70 kg block. And since there is a acceleration of the frame of reference in the downward direction, the centrifugal force would act on upward direction, which is equals to mv square by r. Okay, and the acceleration of the 70 kg block with respect to this aeroplane is equals to 0. So we can write out here n plus mg minus mv square by r is equals to 0, or array acha, is equals to 0. But pen fluctuated for a moment. So out here n is equals to mv square by r minus mg. Okay, the third portion of the question is when the aeroplane is out here, when the aeroplane reaches out here. Okay, so out here this would be the weighing scale and this would be the block. Okay, if I draw the free body diagram out here, this is the 70 kg block. Okay, the normal reaction force, and this is the weighing scale. This is the weighing scale. Okay, the normal reaction force on the 70 kg block would be towards this direction. This is the direction of normal reaction force. The value of mg force would be in this direction, and the value of centrifugal force. See, out here the aeroplane has a centripetal acceleration towards this direction. So out here centrifugal force would be mv square by r. Okay, so although the block is slipping down a little bit, there is no horizontal component of acceleration from this frame of reference, or from the frame of reference of the plane. So out here n minus mv square by r is equals to 0, because there is no horizontal component of acceleration from the frame of reference of the aeroplane. Understood? So out here I can easily write n is equals to mv square by r. Okay, now this is at the midpoint, this is at the bottommost point, and this is at the topmost point. Okay, when you plug in the values, m is equals to how much? 70, v is equals to 100, and r is equals to how much? 500, and the value of g can be taken as 9.81. We get the value out here at the bottommost position. If we plug in the values of m, v, and r, we get the value n is equals to how much? 2.1 Newton. Okay, sorry, 2.1 kilonewton. I forgot to multiply by 1000. Okay, out here, if you plug in the value at the topmost point, it would be 0.7 kilonewton. Okay, that means the weight of the block is 0.7 kilonewton out here. Okay, and if you plug in the value out here, we'll get the value is equals to 1.5 kilonewton. So at the lowermost point it would be how much? 2.1 kilonewton. At the uppermost point it would be 0.7 kilonewton, and at the middle point it would be how much? 1.5 kilonewton. 1.5 kilonewton. So this is our question. See, what this question is saying is that there is a pendulum, okay, attached like this. The pendulum has a mass m that is making an angle 90 degree with the vertical. Okay, the question is asking find the total acceleration. Okay, that means what? This pendulum will come down. So at certain instant when the pendulum is making angle theta with the vertical, that means when the pendulum is in this position. Okay, find the total acceleration when the pendulum is making angle theta with the vertical. That is our question. Okay, so out here, see, one thing you need to learn in pendulum motion is the velocity or the motion of the pendulum will always be perpendicular to the direction of tension. Okay, or will always be perpendicular to the length of the string. Understood? So the velocity of pendulum mass is V out here. Okay, so let's draw a free body diagram. Mg is acting downward, T is acting in this component. Okay, so out here this mg would be broken down into, what is this angle? This angle is theta. Why? See, draw two straight line. If this angle is theta, this angle is also theta. See, parallel lines, and this is the intercept. This angle is theta, this angle is also theta. So out here this gravity force would be mg cos theta, and out here force would be mg sin theta. Okay, okay. So out here this mg is component to mg cos theta and mg sin theta. Now see, since the pendulum is moving in this circular path or in this circular path, there are two components of acceleration out here. One is the tangential component of acceleration, okay, and another one is the centripetal component of acceleration. The tangential component of acceleration is nothing but the rate of change of this velocity, and the centripetal component of acceleration that is directed towards the center is nothing but v square by r. V square by r, or centripetal acceleration at this point is equals to how much? Is equals to v square, or velocity at this point square, divided by r, or divided by the length of the string. Okay, so out here r is nothing but length of the string. Okay, or l is nothing but length of the string. Okay, so let us first find the component of tangential acceleration. See, out here along this direction, okay, along this direction, what is the value of velocity, or what is the value of acceleration, or value of acceleration along this direction, known as tangential acceleration? So I can easily say mg sin theta, okay, is equals to mass into tangential acceleration, or value of tangential acceleration is equals to g sin theta. G sin theta. Okay, now to find the value of centripetal acceleration at this point, the value of centripetal acceleration is equals to v square by r, or v square by l, where l is the length of the string. How do I find out the velocity at this point? See, can I say the velocity at this point, okay, is equals to, see, what I'm trying to do is I'm trying to use work energy theorem. Change in kinetic energy is equals to work done by all the forces. So kinetic energy at this point minus kinetic energy at this point, or final kinetic energy minus initial kinetic energy, is equals to work done by all the forces. Work done by gravity plus work done by tension. So kinetic energy final minus kinetic energy initial is equals to work done by all the forces. Work done by gravity plus work done by tension. See, in pendulum motion, work done by tension is always equals to 0. Why? Because in pendulum, tension is always perpendicular to the motion of tension force. Okay, so tension force is always perpendicular to the motion. Understood? So cos 90 t dot x or dx dot cos 90 is nothing but 0. So work done by tension force will always be 0 in pendulum motion. Okay, work done by gravity. So out here gravity force will always act downward. Okay, and what does this much value? This much value is nothing but L cos theta. Okay, this much length is nothing but L cos theta. So this much length, L cos theta. So the work done by gravity force would be m into g into L cos theta. L cos theta. Okay, fair and fine. What is kinetic energy final? Half mv square. Final kinetic energy is equals to half mv square. What is initial kinetic energy? 0. Initial velocity out here was equals to 0. This is given in the question. So out here half mv square is equals to mgl cos theta. Out here my objective is to find out the velocity. Why? because I want to find out the centripetal acceleration, which is equals to v square by r. So v square is equals to 2gl cos theta, 2gl 2gl cos theta. A centripetal component of acceleration is equals to v square by r, or 2gl cos theta by l, or v square, which is 2gl cos theta divided by r, which is equals to l. L and L would get cancelled, or centripetal component of acceleration would be 2g cos theta. So out here, tangential component of acceleration is equals to how much? G sin theta. And centripetal component of acceleration is nothing but 2g cos theta. Out here, centripetal component of acceleration is nothing but 2g cos theta. Okay. Now to find out the total acceleration. But total acceleration is equals to how much? Acceleration total is equals to perpendicular or tangential component square plus centripetal component square. Okay. Or is equals to under root of, what is the tangential component? G cos or G sin theta. G sin theta square. Plus what is the centripetal component? 2g cos theta. 2g cos theta square. Okay. Or out here, if I divide this, I take g common. Okay. G square common. Sin square theta plus 4 cos square theta. Okay. So this is the value of centripetal acceleration. Sorry, this is the value of total acceleration. See, sin square theta plus 4 cos square theta can be written as, this 4 cos square theta can be divided into 3 cos square theta plus cos square theta. Okay, so this 4 cos square theta can be written as 3 cos square theta plus cos square theta. Okay, or out here, I'm just rearranging this. Okay, plus cos square theta plus 3 cos square theta. Okay, I'm dividing the 4 cos square theta into cos square theta plus 3 cos square theta. Now sin square theta plus cos square theta is equals to 1. So this entire value would be equals to 1. So let's erase this and make it equals to 1. So g square into 1 plus 3 cos square theta. So g square into 1 plus 3 cos square theta is the value of the acceleration. Okay. So in this slide, v square is equals to 2gl cos theta. So remember, velocity is equals to under root of 2gl cos theta. Okay. Now the second part of the question is asking, find the tension in the wire, find the tension in the thread. Okay, find this tension in the thread when the vertical component of this velocity is maximum. So when this vertical component or the component of velocity along this line is maximum. So how much is this much angle? So if I say this angle is theta, if I draw a straight line out here, that means this much angle also is equals to theta. This straight line and this velocity line would make a 90-degree angle. So if this is theta, this is nothing but theta dash. Okay. So out here, vertical component of velocity Vy is equals to V cos theta dash. Okay. Or V cos 90 minus theta. Cos 90 minus theta is nothing but sin theta. So V sin theta. Okay. So out here, Vy would be 2gl cos theta, which is the value of velocity. Okay. Into, see, Vy is equals to under root of 2gl cos theta into sin theta into sin theta. So Vy is equals to under root of 2gl cos theta. If I bring this sin theta inside square root, it becomes sin square theta, no? So sin square theta. Okay. Now the question is asking when the y component of this velocity is maximum. So whenever maximum or minimum is required, we differentiate and make it equals to 0. So can I say the y component of velocity will be maximum when cos theta into sin square theta is equals to, or when d of cos theta into sin square theta is equals to maximum. So when the product of cos theta and sin square theta would be maximum, then only this velocity in y component would be maximum. So whenever maximum or minimum is required, we differentiate and make it equals to 0. So the differentiation of this would come as cos theta into 2 sin theta plus 2 sin theta cos theta, okay, plus sin square theta into minus of sin theta is equals to 0. We took this as constant, differentiated this term, and then took this as constant and differentiated this term, okay, or 2 sin theta cos square theta minus sin cube theta is equals to 0, okay. So out here the solution comes out as, if I take sin theta common, 2 cos square theta minus sin square theta is equals to 0. So from this solution, either sin theta is equals to 0. So at sin theta is equals to 0, the y component of velocity would be minimum. Obviously, the magnitude of velocity is maximum in x component, but that magnitude of velocity is entirely acting in x component, no? So at theta is equals to 0, what happens? The y component of velocity is minimum. So the remaining solution, 2 cos square theta minus sin square theta could also be 0 at this value. So at this value of theta, it would give us the maximum value. So out here, sin square theta is equals to 2 cos square theta. If I take sin square theta to the right hand side, and sin square theta divided by cos square theta, I took cos square theta to the left hand side, okay. Then sin square theta by cos square theta is nothing but tan square theta, okay. Tan square theta is equals to 2, and tan theta is equals to under root of 2, okay. Or the value of theta would be maximum, or the y component of velocity would be maximum when tan theta is equals to root 2. So tan theta is equals to root 2. Now the question is asking, what is the tension out there? So if we draw the tension force, see the diagram, tension force, and this component of mg force was mg cos theta, and the velocity was how much? 2gl cos theta, 2gl cos theta, okay. This was the velocity out here, okay. So can I write tension force minus mg force? Tension force minus mg cos theta is equals to mass into acceleration, and the acceleration out here is nothing but centripetal acceleration, the centripetal acceleration that is directed towards the tension force. So tension for the centripetal acceleration, we find out how much was the centripetal acceleration. It was nothing but 2gl or 2g cos theta. See, in the previous diagram, the value of centripetal acceleration was 2g cos theta, okay, v square by r, okay. So t is equals to, or t is equals to 2 mg cos theta, 2 mg cos theta, 2 mg cos theta plus mg cos theta. This mg cos theta would go to the right hand side, plus mg cos theta. So it would become 3 mg cos theta. So this becomes 3 mg cos theta. So the value of tan theta is equals to root 2. Now if you draw a right angle triangle, okay, right angle triangle theta, the value of tan theta, that means root 2 1. How much is the hypotenuse? The hypotenuse is nothing but root 2 square, or 2 plus 1 under root of 3. So cos theta is nothing but 1 by root 3. Cos theta is nothing but base by hypotenuse is equals to 1 by root 3. So this 3 and this 3 would get cancelled. 3 can be written as root 3 into root 3, no? So root 3 and 1 of the root 3 would get cancelled. So this is nothing but T is equals to root 3 mg. So tension force when the vertical component of velocity is maximum is under root 3 mg. Tension force is equals to under root of 3 mg. And the theta when this happens, under root 3 into mg, not under root 3 mg. Okay. And the value of theta when that happens is equals to when tan theta is equals to root 2. Okay, when theta is equals to tan inverse root 2. Now the third part of the question is asking, find the angle between thread and the vertical at the moment when the total acceleration vector of the sphere is directed horizontally. That means the component of this acceleration plus this acceleration would be in this direction. Okay, so that would happen when the vertical component of centripetal acceleration would cancel out the vertical component of tangential acceleration. So let me say, if this is the vertical line, how much is this much angle? This much angle is nothing but theta. Why? Because this forms a z. Okay, parallel lines, and out here intercepts. So this angle is nothing but theta. And how much is this angle? This angle is 90 minus theta. Why? Because if we draw a straight line, this would be theta, and this entire angle would be 90. So this would be 90 minus theta. So we would have an horizontal component of acceleration, or the summation of this acceleration vector plus this acceleration vector would be on the horizontal line when the vertical components gets cancelled. Okay, only when the y component of this vector is cancelling out the y component of this vector, then only we'll get a acceleration in next component, no? So how does they cancel out each other? So AC cos theta should be equals to AT cos theta dash, or AT sin theta. Theta dash is nothing but 90 minus theta. What is the value of AC? 2g cos theta into cos theta. What is the value of AT? G sin theta into sin theta. So 2g cos square theta is equals to g sin square theta. Okay, g and g would get cancelled, or tan square theta is equals to tan square theta is equals to 2. Okay, so tan square theta is equals to 2 out here. So in this direction, this is the value of theta. Okay, so this, or tan theta, would be under root of 2. Okay, so this is under root of 2, perpendicular base is 1, the hypotenuse is under root 3. So or theta is equals to tan inverse root 2, or theta is equals to tan inverse root 2. Okay, so let's read the question. A ball is suspended by a threaded swing in a vertical such that its acceleration values in the extreme and lowest position are equal. Okay, find the threaded deflection angle in the extreme position. So my first question is, what are the extreme and lowest position? See, whenever there is a pendulum swinging motion, no? Suppose I kept a pendulum out here, making an angle theta with the horizontal, theta with the vertical, sorry. Okay, what will this pendulum do? This pendulum will move like this. Okay, out here the velocity of the bob, or velocity of the pendulum, is equals to 0. Out here the velocity of the pendulum is equals to maximum. Again the velocity of the pendulum is equals to 0 out here. So the pendulum, the motion of the pendulum would be somewhat like this. Okay, out here velocity is equals to 0, velocity is equals to 0, and out here velocity is equals to maximum. Okay. These are known as the extreme positions, and these are known as the lowest position. Okay, the question is asking, find out the value of theta such that the total acceleration out here is equals to the total acceleration out here. Find out the value of theta such that the total acceleration at this point, at extreme point, is equals to total acceleration at the lowest point. So at extreme point, extreme point, there are only two components of acceleration, okay, tangential and centripetal. So tangential acceleration is equals to g sine theta, okay. The force is equals to mg, the component of force along this direction would be mg sine theta, and mg sine theta is equals to ma. So tangential acceleration is equals to g sine theta. See, at extreme point or this point, velocity would be equals to 0. So centripetal acceleration would be equals to 0. Okay. So total acceleration at extreme point is equals to g sine theta. Okay. Now at the lowest point, okay, there would be some velocity v out here. Okay. And what is the tangential acceleration? See, if I draw the free body diagram, m t mg, is there any tangential component of force, or is there any force in this direction? No. So at lowest position, at lowest position, tangential acceleration is equals to 0. Why? Because there is no tangential component of force. Okay. Now I need to find out the value of centripetal acceleration. Okay, t minus mg is equals to mv square by r, where v is equals to velocity. Okay. So out here, what is the velocity out here? A centripetal acceleration at the lowest point is equals to v square by r, or v square by l, where l is the length of the pendulum, or l is the length of the pendulum string. Okay. To find out the value of v, we must use work energy theorem. So out here, the kinetic energy out here minus kinetic energy out here is equals to work done by gravity forces between these 2 points. So work done by gravity forces, this distance is nothing but L minus L cos theta. Okay, L minus L cos theta. So this much distance minus this much distance is equals to this much distance. Okay, so work done by gravity, or half mv square, that is the kinetic energy at this point, minus 0 kinetic energy at this point, is equals to mg, and the work done by gravity is L minus L cos theta. Okay, so out here the work done by gravity is only from this much to this much, no? Okay, we have done in regular mechanics this derivation. So m and m gets cancelled. V square is equals to 2g L minus L cos theta, or I can take the L common, 2gl 1 minus cos theta, 2gl 1 minus cos theta. Okay, or v square by L is nothing but 2gl 1 minus cos theta by L. Okay, so outer L and L will get cancelled. So the tangential or the centripetal component of acceleration is nothing but 2g 1 minus cos theta. So the total acceleration at lowest point is equals to 2g 1 minus cos theta. Now the question is asking what must be the value of this theta. So the acceleration out here is equals to acceleration out here. Okay, so this value of acceleration is equals to this value of acceleration. So can I say g sine theta is equals to 2g 1 minus cos theta. Okay, g and g would get cancelled. So out here sine theta is equals to, or sine theta is equals to 2 minus 2 cos theta. Okay, or sine theta plus 2 cos theta is equals to 2, or minus 2 is equals to 0. Minus 2 is equals to 0. See, this is nothing but a quadratic equation. This out here is nothing but a quadratic equation. Now you might ask how. Okay, let's solve this quadratic equation. Okay, I'm very bad at trigonometry, so I'll solve this by basic method. Okay, this is theta, this is perpendicular, this is base, this is hypotenuse. Okay, so sine theta, that is perpendicular by hypotenuse, plus 2 cos theta, that is 2 into base by hypotenuse, is equals to 2. What I've done is I've sent this 2 to the right hand side. Okay, now take LCM. Perpendicular plus twice of base is equals to 2 into hypotenuse. I've taken age in the hypotenuse LCM and send it to the right hand side. Now I also know that perpendicular square plus base square is equals to hypotenuse square. Okay, from Pythagoras theorem for squaring both left hand term and right hand term. This square, this square. Okay, so it would be a square plus b square, sorry, a plus b whole square, or p square plus 4b square plus 2 into 2b into p is equals to 4pb is equals to 4h square. H square can also be written as p square plus b square, 4 into p square plus b square. Okay, or perpendicular square plus 4 base square plus 4 perpendicular into base is equals to 4 perpendicular square plus 4 base square. Okay, 4b square gets cut. Okay, and what is left? P square goes to the right hand side and becomes 3p square. So out here, this p square will go to the right hand side, it will get subtracted from 4p square. So 4pb is equals to 4p square minus p square is equals to 3p square. If I divide the left hand term and right hand term by p, so divided by p will be nothing but p square and p, or 4b is equals to 3p, or 4 by 3 is equals to p by b. Okay, so perpendicular by base is equals to 4 by 3. So I can automatically deduce that theta is equals to 53, h is equals to 5. You have learned that in basic trigonometric classes. 53 degree, 37 degree. Okay, 4, 3, 5. So out here the value of theta is equals to 53. Value of theta is equals to 53 out here. See, out here the question is asking a ball starts or a block starts sliding out here. Okay, so it's sliding down and down. So as it goes down and down, the velocity of the block increases. So at certain point it will fly off. Okay, instead of rolling down, it will fly off. So the question is asking what is the point, okay, or what is the angle theta at which this block loses the contact from the cylinder. Okay, find the angle theta. So all I'm saying is the block loses contact. Okay, the block loses contact when normal contact force is equals to 0. Loses contact when normal contact force is equals to 0, or the value of n is equals to 0. Okay, so you have to find out the value of n. So before finding out the value of n, how much is this much distance? See, this entire distance is L. This much distance is L cos theta. Okay, so this much distance would be L minus L cos theta. So this much distance is nothing but L minus L cos theta. Okay, now let's draw the free body diagram of the body. So suppose the velocity out here is equals to 0. So initial velocity out here is equals to 0. Q is equals to 0 out here. The final velocity before breaking off is equals to v. Okay, so between this point and this point, can I apply work energy theorem? So can I say final kinetic energy minus initial kinetic energy half? Initial kinetic energy is 0. Okay, half m into 0 square is 0 is equals to work done by gravity forces plus work done by normal forces. And is there any friction? There is no friction on the body. Okay, see, work done by normal forces is always equals to 0. Why? because displacement is always perpendicular to the normal force. Okay, or half mv square is equals to, what is the work done by gravity forces? Mg into L into 1 minus cos theta, or m into g into L minus L cos theta. If I take L common, it would be 1 minus cos theta. So out here, m and m would get cancelled. V square is equals to 2gl 1 minus cos theta. Okay, so just before breaking off, what is the normal contact forces out here? The value of normal contact forces would be in this direction. Okay, the velocity is in this direction, so the acceleration or centripetal acceleration would be in this direction, which is equals to v square by r. And what are the other forces? The other forces are mg. See, centripetal acceleration is in this direction, ac is equals to v square by r. Asha, out here mg forces. Okay, and if this is theta, this angle is theta, this angle is also theta. So in this direction it would be mg cos theta, mg cos theta, and the perpendicular direction it would be mg sin theta. Okay, now I'm drawing this component of equation. Okay, so mg cos theta minus n, mg cos theta minus n is equals to mass into acceleration. And what is acceleration? V square by r, or mv square by r, or v square by r is nothing but the centripetal acceleration. So when the block breaks contact, the value of normal reaction force is equals to 0. Okay, so out here mg cos theta is equals to m. What is the value of v square? The value of v square is nothing but 2gl 1 minus cos theta, 2gl into 1 minus cos theta divided by r, where r is nothing but the uh, L out here. Okay, r is nothing but L out here, or L out here, or the length of this entire thing. L and L will get cancelled, m and m would get cancelled, g and g would get cancelled. So you get the equation cos theta is equals to 2 into 1 minus cos theta, or cos theta is equals to 2 minus 2 cos theta. Okay, or 3 cos theta is equals to 2, or cos theta is equals to 2 by 3. So theta is equals to cos inverse, and theta is equals to cos inverse 2 by 3. The block would break contact. Okay, now the second part of the question is find the break off velocity. That means find the velocity when that happens. So the velocity when that happens is equals to cos theta is equals to 2 by 3, or this value of cos theta would be equals to 2 by 3, 2 by 3, or v square is equals to 2gl, or L is equals to r out here. Okay, 1 minus 2 by 3, or 1 minus 2 by 3 is nothing but 1 by 3, 1 by 3. Okay, or v is equals to 2 by 3 gl. Okay, or v is equals to under root of 2 by 3 gl. So that is the final answer. So velocity is equals to under root of 2 by 3 g into L, where L is equals to r out here. The value of L is equals to the value of r out here. What is being said here is this rod is connected to this L-shaped rod. Okay, and out here there is a bolt, and this bolt is allowed to freely move up and down. Okay, and this bolt is connected to a spring that has a spring constant x. That means what we usually use in mechanics is used as x in irodov. Okay, spring force is equals to kx. Okay, force of spring is equals to kx. Okay, or k delta x. Instead of using k, they have used x out here. So we'll use k in our problem only. K into delta x. K into delta x. A spring coefficient or spring constant into change in length. Okay. Now as this L-shaped rod rotates, this bolt rotates in a circular orbit. The question is asking find the elongation in the spring or find the value of delta x of this spring. So if we see the same diagram from top, okay, what will happen? This is a spring, this is the rod, and this rod is connected to a spring. Okay, this rod is connected to a spring, and out here there is the bolt. Okay, and it is rotating omega in this side. See, this rod is nothing but this rod, and this rod is nothing but this rod. It is moving in a circular orbit. So let's draw the circular orbit. Acha, what is the radius of the circular orbit? The radius of the circular orbit is nothing but this one. Okay, so let this angle be theta. Now we'll draw the free body diagram of the bolt. Okay, okay. See, this bolt is moving in a circular orbit with uniform angular velocity. So the tangential velocity out here would be constant, no? The tangential velocity of the bolt is constant. Okay, out here the spring force. Okay, the spring force. See, as the bolt tries to move in the circular orbit, the bolt will try to move outward. If there was no spring, what would happen? The bolt would try to move outward and escape from this one. Okay, so what is the spring force doing? The spring force is pulling the block or pulling the bolt upward. Okay, so pulling the bolt upward. See, we are seeing this from top view. Okay, that means the gravity or mg force is inside the plane of the screen. Okay, now my next question is, what is the direction of normal reaction force? This side is normal reaction force or this side is normal reaction force, n1 or n2. Okay, just apply some common sense. Okay, this velocity is constant. Why? Because omega is constant. So the velocity along this direction is constant. Okay, velocity along this direction is constant. So there is no component of tangential acceleration. Okay, so somehow this spring force must be cancelled out by normal reaction force, because there are no other forces acting on this body. Mg force is acting, but that is inside the plane of paper. In this plane or in this circular plane or in this horizontal plane, apart from kx and normal reaction force, there is no other force. Okay, and since the tangential component of there is no tangential component of acceleration, therefore that kx must be balanced out by normal reaction force. If we do the normal reaction force out here, both the kx and normal reaction force would get added in this direction. Okay, and it would give a wrong parameter of tangential acceleration. So therefore the normal reaction force has to cancel out a component of normal reaction force, has to cancel out the component of spring force along the direction of velocity. So the normal reaction force would be in this direction. Okay, now see, this is the direction of velocity, this is the direction of velocity, this is the direction of radius. So you are drawing our radius. Okay, the angle, this line and this line makes an 90-degree. So if this line is, or this line and this line makes an angle theta, what is this angle? See, if I draw a straight line out here, this angle was theta. So this angle is also theta. This angle is theta, this is theta dash, this angle is theta dash, then this angle is theta. See, this angle 90, this angle 90. Okay, now you have to find out the value of delta x. So out here, k into delta x, k into delta x. Okay, we know that tangential component of acceleration is equals to 0. So what is the tangential component? First we'll draw the tangential component. Tangential component. component of forces. Can I say K delta X into cos theta? K delta X into cos theta, that means component of the spring force along this direction, is equals to N1 into sine theta. See, if this is theta, this would be theta dash, or N1 cos theta dash, or cos 90 minus theta, or N1 sine theta, is equals to N1 sine theta. Okay, since there is only one reaction force, let's not name it N1, let's name it normal reaction force. Okay, so this is the tangential component of force. Okay, from here, can I write N is equals to K delta X? I'm sending this sine theta to the left hand side. Cos theta by sine theta is nothing but cot theta. Cot theta. Okay, so this is our equation number 1. Okay, for equation number 2, we'll get the centripetal part or radial part. Okay, what is the radial component of force? The radial component of force is K delta X cos theta dash, or K delta X sine theta, plus N cos theta. And if this rod is moving with omega angular velocity, this rod will also move with omega angular velocity. So this rod is also moving with omega angular velocity. Understood? So if I write down the equation for radial part, for radial component or centripetal component, K delta X cos theta dash or sine theta plus N cos theta is equals to M omega square R, is equals to M omega square R. This is our equation number 2. Okay, our equation number 1 was this one, equation number 2 was this one. Now we got these two equation, the tangential component and the radial component of equation. Now let's solve this equation. So we'll modify this radial component. I'm dividing left hand side and right hand side by cos theta. So K delta X sine theta by cos theta is nothing but tan theta plus N is equals to M omega square R divided by sine theta, sorry, divided by cos theta, which is equals to sec theta. I divided the entire term, the left hand term and the right hand term, by cos theta. So K delta X sine theta by cos theta is nothing but tan theta. N cos theta by cos theta got cancelled, and M omega square R by cos theta is nothing but M omega square R sec theta, because 1 by cos theta is equals to sec theta. Now what we'll do is we'll substitute the value of N out here. So K delta X tan theta plus what is the value of N? K delta X cot theta is equals to M omega square R sec theta. Okay, now if there is a triangle of theta, okay, perpendicular base, and this is hypotenuse, so I'm out here, I'm taking K delta X common, tan theta plus cot theta is equals to M omega square R sec theta. Now solve this value of tan theta plus cot theta. Tan theta plus cot theta, what is tan theta? Tan theta is nothing but perpendicular by base, so perpendicular by base. And what is cot theta? Base by perpendicular, base by perpendicular, base by perpendicular. So if you take LCM, okay, BP is nothing but perpendicular square plus base square. And what is perpendicular square plus base square? It's hypotenuse square. So from Pythagoras theorem, perpendicular square plus base square is equals to hypotenuse square. So is equals to nothing but hypotenuse square by BP, or is equals to hypotenuse by B into hypotenuse by P. What is hypotenuse by base? Base by hypotenuse is cos theta. So hypotenuse by base would be nothing but sec theta. Sec theta into how much? Cosec theta. cosec theta, or hypotenuse by perpendicular is cosec theta, because perpendicular by hypotenuse is sin theta. So out here tan theta plus this entire term, tan theta plus cot theta, would become sec theta into cosec theta. So out here sec theta into cosec theta, sec theta into cosec theta. Now this sec theta and sec theta would get cancelled. Okay, sec theta and sec theta is getting cancelled. So our equation comes out to be k delta x cosec theta is equals to m omega square r. Okay, or k delta x cosec theta, k delta x cosec theta is equals to m omega square r. And what is cosec theta? 1 by sin theta. Okay, now problem is, what is this value of r? R is nothing but this length. Okay, this length is nothing but r. Now what is this length? This length is nothing but length of the spring, or initial length of the spring, plus delta x, or elongation of the spring or compression of the spring. Okay, so out here the initial length of the spring plus elongation of the spring. This spring is elongated, that's why the force of spring is in upward direction, no? So out here this entire length is x plus delta x. Okay, now can I use, see, perpendicular or sine theta? See this diagram, sine theta is equals to x plus delta x divided by r, x plus delta x divided by r, or r is equals to x plus delta x divided by sine theta. Okay, out here the spring is elongated, that's why x plus delta x, that's why the spring force is in upward direction. Okay, so out here r is nothing but, or r is equals to x plus delta x into 1 by sine theta is nothing but cosec theta. So out here k delta x cosec theta is equals to m omega square. What is the value of r? X, initial length of the spring, plus elongation of the spring, into cosec theta. Cosec theta and cosec theta got cancelled. So out here our equation becomes k delta x is equals to m omega square x plus delta x. Okay, now what the question is asking is the elongation of the spring per unit length. That means they're asking a value of delta x by x. See the question properly, this is being asked. Okay, so how do we do that? We divide the entire left hand side by x. K delta x by x is equals to m omega square 1 plus delta x by x. Okay, divided left hand side and right hand side divided by x, or initial length of the spring. So can we isolate this value? Of course, or k delta x by x is equals to m omega square plus m omega square delta x by x. So we isolate all the values. K delta x by x minus m omega square delta x by x is equals to m omega square, or out here delta x by x is equals to m omega square by k minus m omega square. So this is our answer. Okay, in this question what is being said is that there is a circular field. Okay, now in this circular field what happens is, as I move away from the center of the field, what happens, the grass is very bad, or the grass wears out. So as I move away from the center of the field, the coefficient of friction, okay, becomes very less, and that relation is given by, suppose this is the center, the coefficient of friction out here is very high, the coefficient of friction out here at the outer surface of the field is very low. Okay, suppose I want to find out the coefficient of friction out here at this point. So the coefficient of friction would be given by the relation mu is equals to mu naught 1 minus r by capital R, where r is the distance from the center, capital R is the radius or total radius of the field. Okay, see this relation in irodov they usually mention coefficient of friction as k, so instead of writing k I'm writing mu naught. Okay, mu and mu naught. Okay, let me do this in a better way. Out here coefficient of friction mu is equals to mu naught. Okay, now the question is asking a cyclist has to travel in a circular path. Okay, the cyclist has to travel in a circular path in this field. The question is asking find the value of r so that the cyclist has maximum velocity. Find the value of r so that the cyclist can have maximum velocity. So I get the intuition that we have to make an equation of v and r, v as a function of r, and then make dv by dr is equals to 0. Okay, this is my approach for the question. Whenever maximum or minimum is asked, just differentiate and make it is equals to 0. The approach for all maxima or minima are same as this one. Okay, make a function with respect to a variable that is being asked in the question and differentiate and make it equals to 0. Now see what will I do. Out here when the cyclist is traveling in a circular path, where is the centripetal force towards the center, and who is providing the centripetal force? The centripetal force is being provided by the friction force. Okay, or friction force is providing that centripetal force. And what is the value of friction force? Mu into n, where n is equals to mg. See, the ground will provide n upward and the mass of the cyclist is m. So friction force is equals to mu mg out here. So can I say friction force is equals to mass into centripetal force, or mu mg, that is the value of friction force, is equals to m into v square by r. So m and m will get cancelled. Sorry, m and m would get cancelled, and our value would be v square is equals to mu gr. Okay, problem out here is the coefficient of friction is not constant for every radius. The coefficient of friction varies as I increase the value of r. So if I substitute this mu out here, what do I get? V square is equals to mu naught 1 minus r by r into gr. Okay, so the velocity of the cyclist will depend upon the radius r as this function. So for maximum of this function I must make dv by dr is equals to 0 and find the value of small r. So my main approach in this question would be this one. So out here if I multiply, or v square is equals to mu naught gr minus mu naught g r square by capital R. Okay, so out here what is velocity? Velocity is nothing but v square, or 2v dv by dr. What I'm doing is I'm differentiating this entire term with respect to r. So 2v dv by dr should be equals to, I have to differentiate this entire term with respect to r. So if I differentiate it, it would be mu naught g minus 2 mu naught g by gr by capital R. Okay, or dv by dr, should I apply chain rule out here? See, I apply chain rule out here. Okay, dv square by dv into dv by dr is equals to mu naught g minus 2 mu naught gr by 2v, and for maximum and minimum this value should be equals to 0. Okay, so is equals to 0. Out here I made a little bit of mistake. It is r by capital R. I forgot the capital R out here. So r by capital R. Now when I solve these two equation, okay, I'm solving this equation, or I'll get mu naught g minus 2 mu naught g r by capital R is equals to 0. I just multiplied 2v to the right hand side. Okay, or I can simply say mu naught G is equals to 2 mu naught G R by capital R, or mu naught G and mu naught G would get cancelled, or R is equals to capital R divided by 2. See, so the value of R, so at R is equals to R by 2, at R is equals to capital R by 2, that means exactly at the midpoint between the radius. In this orbit, the cyclist can travel with maximum velocity. Okay. Okay. So what is this velocity? The second part of the question is what is this velocity? The equation of velocity is this one. So we simply plug in the value of small r to capital R by 2 and get the answer. So v square is equals to mu naught G. What is the value of small r? Capital R by 2 minus mu G R square, or R by 2 whole square divided by R. Okay. Or v square is equals to mu naught G R by 2 minus mu naught G R by 4. Okay. So 1 by 2 minus 1 by 4 is nothing but v square is equals to mu naught G 2 by 8, or 1 by 4. Mu naught G R by 4, or v is equals to under root of mu naught G R by 4. Okay.